So I should now be recording. So I thought I'd just do a quick maths question. It's D'Alembert's method that we're asked to. This is a mathematics engineering exam, but it's obviously applicable to any mathematics exam that has this method as a part of it. So as you can probably tell, with these partial differentiation equations, we can use several methods, but here it tells us to use D'Alembert's. So for those of you who know or don't know or whatnot, let me just see if I haven't got the right pen. Give me a second. Monoline should work. Okay, so it is, never mind, u xt equals fx minus ct, that's my x is a little weird here, plus gx plus ct. And we're going to use this to find out the answers that they're asking. So if we look closely at the question, it's asking us to find a solution to the wave equation that we're given below. And we're also given some initial conditions that can help us solve this. And so we know when t is 0, so when when ux is 0, it equals fx. Therefore, ux0 equals fx plus gx equals fx, because we're assuming these questions here equal 0, so therefore it's just fx and gx. The other initial condition is that the partial derivative when t is 0 also equals 0 in between negative infinity, when x is negative infinity to infinity. Okay, so that gives us the opportunity to integrate the equation, D'Alembert's equation, which gives us this right here. X plus c g. And so this might look, this is very bad handwriting, I apologize. So this might look really quite normal, not very, like I've just been writing waffle, but we can use the two things that we have found to equations. When I do this again, I will have a better, I'll be better at this, so I apologize if this is kind of all over the place. So we're given, so integrating the second equation that we have here, so it's this equation, we can find that it equals this, and we're given a constant. This is the constant. Well, we're not given a constant, but it gives us a constant when we integrate. And now we can combine this equation with 1 to give us this really useful equation. Looks kind of simple, but however, there is a use to this. We can then find gx, as we know that minus fx plus gx equals a. Therefore, gx, so I'm just going to put a little thing so we can differentiate between the two. Differentiate as in tell the difference, not actually differentiate in terms of mathematics. And so we now have fx and gx. Therefore, uxt, I'm just going to write out in full, is this. Half f x minus ct, because obviously the a constant cancels out as you add these two f and x terms together. So let me just put this in red. Sorry, I'm not very good at this. So this is our answer. Cool. So let me just make this smaller so we can do the second part. Okay, so we've done this first question. 6 marks, that's quite a lot. Pretty good, I think, for 6 marks. Now it asks us to, in the case of the function f(x), and then we're given some information about this term, a equals 0 if it isn't when x isn't between -1 and 1. We sketch the solutions, and we're given different values of t to do so, which is very interesting. I'll just go back to my black pen. And so let's do 3 graphs. They're going to be very simple and not very well drawn, so I apologize for that. But if we have 3 graphs, and then there's one more. I can then have, so if I'm just like laying it out quite simply here. So these are just the axes that we're given, and then this is the x-axis, and this is the x-axis. So for when t equals 0, I'm now going to be, I'll just write this down, and then I'll change to the red pen, makes it more clear. See. Okay, now let's think about it. When t equals 0, what would the graph look like? Well, it would look like this with a lump in the middle. And why is that? Well, if we think about it, the ct term cannot equal anything. And we find out that the uxt equals 1 at 0. And then that's it. Okay, on to the next one. Now let's think about it. T equals 2 over c. So we're now, when x is 0, uxt is also 0. However, there are 2 lumps on the side. Sorry for the bad drawing. And if we line these up, this equals 0.5 this time. Now I could prove this all by equation, by putting the values into the equation, and then we find out the value. But if you don't quite understand this, is very good practice to do yourself. You kind of understand how we get there. And then when t equals 4 over c, we essentially do the same, but the 2 lumps become further away, but they still stay at 0.5. So it's like this. And then these are still 0.5. Oh, and I should also mention, because just to make it clearer, this is 0. This is ct, and this is negative ct. And then this is negative ct. This is ct. Okay, so that is it. That's the whole question. You get 10 marks for that. It is, if you don't understand D'Alembert's equation method, it can be very difficult to wrap your head around. But when you have it, you have it. And it's 3 marks when you understand D'Alembert's method. So here's the video. Hope you enjoyed. If it was useful, next time I do a maths video, I promise it will be clearer. But anyway, hope everything's going well. And here's the video for you.